Welcome again. Today we look at synthetic routes using the method of retrosynthesis to look at the end product of a series of reactions and then work backwards from that end product to figure out the best pathway for the manufacture of the end product. So let's go in and take a look.
An understanding of these synthetic routes in organic chemistry is useful if you wanted to synthesize a product like ethyl ethanoate, an ester, and you had to begin your synthesis from chloromethane. To go about thinking or designing how you would do this, retrosynthesis requires thinking in reverse. And for ethyl ethanoate, an ester, you should recall that an ester is the product of the condensation reaction between an alcohol, specifically ethanol, and a carboxylic acid, specifically methanoic acid, giving you the product ethyl methanoate. But this does not come from the starting product. So then it is necessary to further reflect and to see if we can connect one of these, at least, to the starting product. And we realize that methanoic acid can come from methanol by oxidation using acidified potassium dichromate. But methanol is still not the starting product. So if we reflect further, then we would note that methanol, an alcohol, comes from a nucleophilic substitution reaction with dilute sodium hydroxide. An SN2 reaction mechanism is involved. And in this way, we would work backwards from ethyl ethanoate to chloromethane to determine a possible synthetic route using the method of retrosynthesis. Now the question is, what kinds of retrosynthetic pathways are IB chemistry students expected to figure out? And these pathways can only be based on the reactions studied in the course. So here you have some of the classes of compounds that you studied, and you should recall from earlier sections about how you can connect some of these using a diagram so that you can figure out what you can get from what. Let's begin first by putting an alkene at the bottom. Then you should recall that it's possible to go from an alkene to an alkane by hydrogenation. Another possible pathway is to go from an alkane to a halogenoalkane. This would involve removal of one of the hydrogens. It's possible to remove two hydrogens and to go to a dihalogenoalkane. From a halogenoalkane, it's possible to remove the chlorine and to form an alcohol. This particular reaction known as a nucleophilic substitution reaction. From an alcohol by oxidation, depending upon whether that alcohol is primary or secondary, you can then derive a ketone or an aldehyde. And an aldehyde can be further oxidized into carboxylic acid. And then an ester can be formed by combining carboxylic acid with an alcohol. These three remaining structures, benzene, nitrobenzene, and phenylalanine, are aromatic pathways or pathways involving arenes or compounds that contain the benzene aromatic ring. From benzene, we can nitrate benzene to form nitrobenzene, and that allows for the formation of phenylalanine. And these are the reactions and the pathways that students of IB chemistry should be familiar with, so that if you're asked to go from an alkene to an alcohol, you would be able to think backwards and say, how do I get an alcohol? I can get it from a halogenoalkane, and I can get a halogenoalkane from an alkane, and I can get an alkene by the hydrogenation of an alkene. And in this way, you would have completed a retrosynthetic pathway for going from an alkene to an alcohol.